Hey there, this is a video for 14.2, Finding Cube Roots. Turn to page 5 in your packet and you will see these problems. You're looking to figure out from the volume of a cube what its side lengths would be. So our sample at the top has a volume of 343 cubic inches. And up above it, you will see up above where I just circled, that we've got a new symbol. This symbol here is the same as what you saw yesterday, except in that little crook on the outside, you've got a 3 to say that you're looking for what number times itself 3 times gives me this number. So 7 times 7 times 7 is 343. So the cube root of 343 is 7. I'd like you to take a look down below at B, C, D, and E. Decide if you can come up with what numbers times themselves 3 times, or what number cubed gives you these volumes. So we've got 27, 125, 0.001. Remember that fraction tip from yesterday, that may help you out, and 1/8. Pause the video and see if you can figure it out. Okay, take a look at what I did. I tried to break it down into parts. So 27 is 3 times 3 times 3. So our cube root of the cube with a volume of 27 cubic feet is that each side has to be 3 feet. For the 125 cubic meter cube, 5 times 5 times 5 is 125. So its cube root is 5. So each side has to be 5 meters. And I shouldn't say side, I should say edge. For D, I broke that down into a fraction. I think that's, again, easier to see at the beginning. But 0.1 or 1/10 cubed is 1/1000th, or 0.001. So each side, each edge is 0.1 centimeters. And for E, each edge is 1/2 yard. So looking at numbers, sometimes you'll see what the cube root might be, and sometimes you won't. So I wanted to show another way to think about how to find a cube root. So this is a factor tree. So you'll see we start with the number 216, made a factor tree for it, and we find that the prime factorization, all those circled numbers in the tree up here, the prime factorization here, we've got these factors. You'll notice that I have 3 2s and 3 3s. So when we put these together here, we can break 216 down into 3 pairs of factors that are all the same. So 216 is 3 times 2 times 3 times 3 times 2 times 2 as up here. But I can rearrange that, it's just multiplication, into 3 times 2 times 3 times 2 times 3 times 2, or 6 times 6 times 6. So the cube root of 216 is 6. So here in the bottom of this page, you'll see 1,000 and you'll see 3,375. Let's make some factor trees to see how this works. So 1,000 is 2 times 500, that's 5 times 100, 5 and 2 are both prime, 100 is 50 times 2, 5 times 10, this is 5 times 2. So when I do this, I find out 1,000 is 2 times 5 times 5 times 5 times 2 times 2. So I want to look for, can I break this factorization down into 3 equal groups? So first I look at the smallest number. So I've got 3 2s, that's good. And then I'm going to look at the 5s. I also have 3 5s, so I can do 5 times 5 times 5. So this is a way to show if you've got 3 of each or a multiple of 3 of each type of factor, you're going to get a perfect cube. So this is 10 times 10 times 10. So the cube root of 1,000 has to be 10. Let me put together the factor tree for 3,375. So I made a factor tree and wrote out the prime factorization right underneath it. And you'll notice I've got 3 3s, 3 5s. So that means the number 3,375 has to be 3 times 5 times 3 times 5 times 3 times 5, or 15 cubed. So the cube root of 3,375 has to be 15. So a cube root of a number is a number that, when multiplied by itself and then multiplied by itself again, equals the given number. A perfect cube is a number that can be written as the cube of an integer. This symbol here, the cube root, is used to represent a cube root. So for A, we need to think about what times itself gives us 8, or think about what factor pairs you know for 8. So if we think of 8, it's 2 times 4, and 4 is 2 times 2. So we know 8 is equal to 2 to the third. Just like with square roots, cube roots and cubing a number cancel each other out. So all these things cancel out. The cube root of 8 is 2. In B, you see something a little different. You'll notice there's a negative sign. Cube roots don't have two different answers like square roots do, because when you multiply something by itself 3 times, like -2 times -2 times -2, that's not going to give you a positive result. In fact, that's going to give you -8. So cube root of 8 really only has one answer. So the cube root of -27, hopefully you remember that 27 is 9 times 3, and 9 is 3 times 3. So that's really -3 to the third, because -3 times -3 times -3 is going to give you the -27. So the cube root of -27 is -3. For C, 1 to the third is 1. 64. Usually think of 64 as 8 times 8. If you think through its factor pairs, factorization, you'll see that it is 2, 1, 2, 3, 4, 5, 6 to the 6th. So 64 is 2 times 2 times 2 times 2 times 2 times 2. So you can break that into pairs. So that means 64, 2 times 2 is 4, is 4 to the third. So when we do this cube root, we get 1/4. And the more you practice this, the more you'll recognize which numbers are perfect cubes. You'll just be using them. You can use that chart that you have at the beginning of the note packet on page 1. That's really helpful. Please do use the chart and use a calculator if you're trying to factor out a big number. Use the tools that you've got. So as I said, cubing a number and finding a cube root are inverse operations. You can use this relationship to evaluate expressions and solve equations involving cubes. By the way, for cube roots and square roots, if you think about the order of operations, PEMDAS, square roots and exponents count in the same level. So if you're ever confused, square roots and cube roots all fit inside the E in PEMDAS, so they come before multiplication, division, addition, and subtraction. So in example A, we've got 2 times the cube root of -216 minus 3. Hoping that you might remember from earlier when we started with the factor trees that 216 is 6 times 6 times 6, or 6 to the third. So that means that -216 itself is the same as -6 to the third. So when we've got that, hopefully you're recognizing that this cube root and cubing the number are inverse operations. So this turns into 2 times negative 6 minus 3. So that this part of the expression just comes down to be negative 6. Multiplication first, we get negative 12 minus 3. Final answer of negative 15. In B, you can clearly see that we're cubing a cube root. You might recognize, hey, the cube root of 125 is 5, but then you right away have to go and cube that result. So instead of going to all that trouble, if you recognize that those are inverse operations, this whole thing simplifies down to be 125. So 125 plus 21 is 146. So now it's your turn. Pause the video and see what you can figure out in these 6 practice problems. And here's all the answers. So the ones at the top were ones we'd seen today or had numbers that we'd seen today. The ones on the bottom, take a look at number 6. 512 is a bigger number than we'd seen, or it wasn't the biggest number we saw, but it was a perfect cube that we hadn't noticed before. So I did a factor tree down here below and showed that 512 is 2 times itself 9 times, which if I put that into 3 groups, that is 8 to the 3rd. So that's where the 8 came from up above. Your assignment is from page 636. It's numbers 9 through 19 odd and 29. Practice this up so that you're ready for the Google quiz on Friday. And tomorrow on Thursday, you will have a fun little puzzle to work out. Have a great rest of your day.